Next we shall see distortionless transmission through a system. Distortionless transmission through a system. What is distortionless transmission through a system? And what is a distortion? Let us consider a system. When I pass this signal as the input to this system, let us consider this is something signal which is I want to transmit through the system, and if I get something other than this, see here, there is a change in the shape of the signal. So, okay, some disturbance is occurred here, and if there is a change in the shape of the input signal at the output side of the system, and we can say that there is a distortion. This is distortion. If there is a change of shape of the signal when it is transmitted through a system, is called as a distortion. Okay, when a system gives the exact replica of the input signal, then the system is said to be distortionless. Let us consider the same another system. Let us consider there is a system. If this system, let us consider if this system produces the same shape, okay, see here, there is something, the input is similar, the output is similar to the input. There is an output is an exact replica of the input, except there is a change in the magnitude. It may have some change in the magnitude. It can have some delay also. Okay, that means output అనేది ఇన్పుట్ ఎట్లా ఉందో అట్లానే ఉండాలి, కానీ ఇంకా కొంచెం పెద్దగా కూడా ఉండొచ్చు, లేకపోతే కొంచెం డిలే కూడా అయినా కూడా పర్వాలేదు. అంటే సో లెట్ us consider the same output ఇలా ఉంది, సారీ అవుట్పుట్ అనేది ఇలా వచ్చింది అనుకుందాం ఫర్ ఎగ్జాంపుల్. ఓకే, అంటే ఇప్పుడు మీరు బాగా గమనించినట్టయితే సో ఇన్పుట్ అవుట్పుట్ ఒకేలాగా ఉంటాయి. సో ఇన్పుట్ అనేది ఇలా ఉంది, ఓకేనా. సో there is a change in the shape. There is no change in the shape of the pulse, but there is a change in the delay. It has introduced some delay. There is a change in the magnitude. Okay, magnitude లో తేడా ఉన్నా పర్వాలేదు, డిలేలో తేడా ఉన్నా పర్వాలేదు, బట్ కాకపోతే షేప్లో మాత్రం ఏం చేంజ్ జరగకూడదు. ఇప్పుడు ఇట్లాంటి అవుట్పుట్ గిన మనకు వస్తే గిన, సో దాట్ సిస్టమ్ ఇస్ సెట్ టు బి distortionless. Yes, that system is said to be distortionless. Okay, so how can we represent that the system is distortionless mathematically? Means let us consider the output is y of t. Y of t is equals to k times x of t minus td, where k is something constant, which is where k can be anything. So it can be greater than 1 or it can be less than 1. So there can be a change in the magnitude, that can be amplification or attenuation. Signal పెద్దగా కూడా కావచ్చు. For example, let us consider, so this is my input. The output can be like this. See here, the output can be like this, where the magnitude is increased much, where it can be like this, where the magnitude becomes much smaller here, magnitude becomes smaller here, magnitude is much larger here. Okay, these two outputs are also considered to be distortionless. Okay, and you can the system may also produce some delay, no problem. The system may also produce some delay, no problems here. This is the actual input, and this is the actual the output of the system, with a change in the large change in the magnitude, and there is a delay with a small with the attenuation of the input and with a delay. Okay, and this can be mathematically represented as y of t is equals to k times x of t minus td, where k can be something constant, where td is something delay. Okay, the delay, this is something, this is td, this is td. So the system has introduced some td delay. Okay, if it is t means, and this goes to td plus capital T, and this goes to td plus capital T. So if the duration of the signal is t means, and td plus capital T. Okay, by taking the Fourier transform on both sides, so what would be the, now we shall see that what would be the frequency response of the system. Okay, how do we get the frequency response of the system once we know the input output relation? So that means y of t is equals to x of t minus, k times x of t minus td. Y of t is equals to k times x of t minus td. So taking Fourier transform on both sides, y of omega is equals to k times, and using time shifting property, e to the power of minus j omega td x of omega. Okay, and from this we can say that h of omega is equals to y of omega by x of omega, that is equals to k times e to the power of minus j omega td. Okay, so from this, where h of omega is a complex quantity, so we can write this as modulus of h of omega e to the power of j times angle of h of omega. By combining, that means this is the phase and this is the magnitude, then modulus of h of omega we can write this as k angle of h of omega is equals to minus omega times td. Okay, if you plot that, the both magnitude and phase, and that will be like this. This is modulus of h of omega, and when we plot this, this will be like this. This is angle of h of omega, this is something minus omega times td. So all the frequencies should be having the same magnitude k. Okay, all the frequencies of the input must undergo with the same amount of amplification or attenuation. That means, let us consider all the frequency components, this is omega, all the frequency components must undergo by the same amount of amplification or attenuation, and here all the frequency components must undergo with the same phase shift, okay, for the system to be distortionless. So practically there is no system with this kind of a bandwidth, which is, that means infinite bandwidth. So no system is exist in practically in nature which is having an infinite bandwidth with a constant k characteristics like this. Okay, so this is all about the distortionless transmission through a linear time invariant system.